Okay, so this is day 2 of the remainder theorem. Okay, so hopefully you remember with the remainder theorem, basically, if you use the 0 of the divisor for the input, then the remainder is the output. Okay, so lucky for you, okay, I went over with my video for 5A, so this whole first page we've already completed. Okay, so we're going to page 15. All right, so this is page 15. And page 15 is mostly homework. All right, page 15 is going to be your homework. The only thing I'm going to talk about is on page 15, for numbers 4 and 5, think about using the graph. Okay, we did some notes, and you don't have to, so use graph. Okay, that would be my advice. All right, I'm not going to put a question mark there. I'll just, okay, use graph. That's my suggestion, because if you use the graph and look at the zeros, from the zeros, you can find the factors. It's working backward. Okay? All right, so we're going to talk about, we're going to do page 16 in this video, and that's it. So page 16 is a video, page 15 is homework. Okay, so it says consider the cubic polynomial. All right, I'm looking at this. I know it's a third degree equation. That means it should have 3 roots or zeros. Okay, of those 3, some could be real, some could be imaginary, but I know that because it's a third degree equation. So I'm just thinking ahead. All right, it tells me to use long division, and I'm going to write my answer in quotient remainder form. All right, so this is the quotient plus the remainder over the divisor, right? And remember, this p of x is just this function. All right, so I'm going to do long division, and then I'm going to evaluate p of 3 using the remainder theorem. All right, so let me rewrite this. So it's x cubed plus x squared, and I'm noticing this is a complete polynomial because all of the exponents are represented. I go from x to the third to x squared to x, and then just to the constant, so that's good. I don't have to add any zero terms. All right, and I'm dividing it by my divisor here, x minus 3. All right, so I'm going to do my long division. And I would suggest you pause the video because you should know how to do long division, and it's nice to practice on your own. All right, so I'm finding the term that I have to multiply by x. That gives me x cubed, and that's x squared. I'm going to distribute my x squared, and then I'm going to subtract. Okay, I'm doing 1x squared minus a negative. Okay, some people like to turn these into positives because a negative minus a negative is a positive. So that gives me 4x squared. I subtract, and then I bring down. Okay, I go back up to the top. I say, okay, what times x gives me 4x squared? Well, that's 4x. And I distribute my 4x to get 4x squared minus 12x. And I subtract. Okay. So first terms cancel. Again, this is a negative 46 minus a negative 12. So it's the same thing as negative 46 plus 12. All right, so I'm going to subtract, and I'm going to get 34. It's a negative 34x plus 80. Yes. Okay, go back to the top. I have to have a negative 34 here to get my first terms to match. So I have negative 34x. And then a negative 34 times a negative 3 will give me a positive, let's see, that would be 90 plus 12, which is 102. Okay, and I'm subtracting these, so first terms cancel, and 80 minus 102 is negative 22. All right, so I'm writing my answer in quotient remainder form. Okay, I'm just gonna check my notes. Okay, so my answer, my quotient is the x squared plus 4x minus 34. And then since it's a negative remainder, I can just put minus down here, and then I can do the 22 over my divisor, x minus 3.
Good morning. Please stand for the pledge of allegiance.
I'm going to stand for the pledge, so I'm going to pause my video.
To the flag of the United States of America and to the republic.
So the long division, ooh, that's pretty. I've never seen that before. The long division is done, and now I am going to evaluate P of 3. And the reason why I'm going to use an input of 3 is because my divisor is x minus 3. Remember, this is called the divisor. And it's 0 would be the number to substitute for x that turns it into 0 would be a positive 3. So the remainder theorem says that I should use that positive 3 as an input into the function p of x. So I'm going to substitute my 3. So I have 3 cubed plus 3 squared minus 46 times 3 plus 80. And again, if you have you can open up Desmos with a scientific calculator. You can type the whole thing in, and it does it for you in quickly in just one step. Just to model that, just because there's less room for error when you're using a scientific calculator. As long as you substitute your values with parentheses around them, I'm going to just do radical, not radical, I don't know where that came from, but 3 cubed. I have a copy of this in my notes. Use it. So I have to go back. Plus 3 squared. And that's not a plus sign. Okay. Minus 46 times 3. And then plus 80. Okay, and you see my answer is right above my picture here. It says, now it's below your picture, your answer will show up on this side, and it says negative 22. So negative 22 should be my remainder. So that helps me check my long division because this represents my remainder. That's what the remainder theorem is. Okay, so now it gives me another input to try. It says evaluate P of 5. Okay, so now I'm going to substitute 5 in for P. So 5 cubed. Please make sure you're always showing your work. So write down your substitution for work. And it's kind of nice because I already have this on my Desmos, so I can actually, I think it's just going to be super easy. I can just go back and change these to 5s. Change my input to 5. And notice it automatically updates, and now if P of 5 is 0, okay? So I know P of 5 is 0, which means if I divide P of x by x minus 5, I get a remainder of 0, okay? This is the remainder again. Okay, so since my remainder is 0, remember, that tells me that x minus 5 is a factor because only factors have remainders of 0 because that means they divide evenly into the function. All right, so instead of writing that whole function, I'm just going to write it's a factor of P of x, which represents that function. All right, so that was easy. All right, now it says if the quotient equals P of x, if Q of x equals P of x over x minus 5, then use polynomial long division to find an expression for Q of x. All right, so basically they want us to divide x minus 5 into P of x to see what, basically this is what we're doing. We know that x minus 5 is one of the factors of P of x. We need to find out what we have to multiply times x minus 5. We're going to find the other factor that gives us that polynomial P of x. That's what we're doing right now. So if we divide P of x by x minus 5, we'll get the other factor. So I'm going to divide P of x, which is again x cubed plus x squared minus 46x plus 80. I'm going to divide that by x minus 5. All right, so I get x squared, let's see, x cubed minus 5x squared. Don't forget to subtract. So this is really 1 minus a negative, which that's the same thing as 1 plus. This gives me 6x squared minus 46x. Bring down my plus 6x. It's a plus 6x. I'm going to distribute. That gives me 6x squared minus 30x. I'm subtracting. So I'm subtracting, turns into a plus. I get negative 16x plus 80. And if I put a negative 16 up here, that gives me negative 16x. And negative 16 times negative 5 is a positive 80. It's looking good, because if I subtract these, they're the same value. That gives me 0. All right, that just confirms then that x minus 5 is a factor. And it also tells me, again, that p of x is equal to x minus 5 times this quotient. So x squared plus 6x minus 16. If I were to multiply these two things, I would get my original function p of x. All right, so now it wants me to completely factor p of x. And besides x equals 5, what are the other zeros? So I know p of x from my work in part C is x minus 5 times x squared plus 6x minus 16. And I know this is not factored completely, because that trinomial can be broken down into two binomials. And since this is a lead coefficient of 1, I can just think of the factors of negative 16 that add up to a positive 6. So I know signs have to be different. And I know 8 times 2 is 16. And in order to get a positive 6, it has to be a negative 2 and a positive 8. So now that I've factored completely, okay, in order to find the zeros, that means my output is 0. This whole p of x would equal 0. I'm going to set each of my factors equal to 0. All right, so we already know that x equals 5. Okay, that goes with this factor. So x equals 5 is one of my zeros. And I don't mind if you skip this step, because it's mental math. But x equals 2 is another 0. And then I'm going to set this one equal to 0. That says x plus 8. My pen is not very accurate. And the other 0 would be x equals negative 8. So the other zeros, okay, the other zeros are negative 8 and 2. Of course, 5 is a 0 as well. So the other zeros, I'll just write it because they specifically asked for the other zeros, are negative 8 and 2. And we are done. So your homework, like I said, is to do page 15, and you can use the Desmos app to graph for numbers 4 and 5, and make sure you show work for the rest. You will not get credit without showing work. All right, so that's the remainder of the remainder theorem. Come on.